Good morning, everyone, dear authors and invited guests. Welcome to Technical Session 4A. Myself, Karthik Bharadwaj, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Solistic LLP, it's my great pleasure to welcome you to the 10th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2025, New York, USA. The 10th edition of the conference is being organized in a hybrid mode. The physical event is being held today in New York, USA, and the virtual event is being held through Zoom today and tomorrow, that is 23rd and 24th May 2025. I hope you will enjoy the knowledgeable and interactive session throughout the day. In this session, we have 8 presentations. Each presenter will be given 12 minutes for their presentation and 3 minutes for question answer. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remark. If you have any query or any update, you can write it to me in the chat box. So let's move forward, and I would like to introduce you with today's session chair, Dr. Tanupriya Chaudhary. Dr. Tanupriya Chaudhary is a full-time professor at University of Petroleum and Energy Studies, Dehradun, specializing in AI/ML application, geoinformatics, brain computing, cloud computing, and disease detection. With more than 15 years of academic and research experience, he has made significant contribution to advancing AI and machine learning applications. Dr. Chaudhary has authored numerous publications in high-impact journals and conferences, and is the recipient of prestigious awards for his innovative work. His research endeavors include leveraging cutting-edge technologies to address real-world challenges. I request our session chair to kindly address our participants.
Thank you, Karthik, for this nice introduction. And thank you all of you for joining on time. And I wish all of you to please present your paper within the timeline so that we can close the session on time. Thank you very much and all the best.
Thank you, sir. Now, I would like to introduce you with our next session chair, Professor Vishnu Kumar. Professor Vishnu Kumar is an associate professor in Department of Industrial and System Engineering at Morgan State University, Baltimore, Maryland, USA. Dr. Kumar is actively engaged in research with publication in peer-reviewed journals and conference proceedings, such as ASME, JCISE, NPJ Mental Health Research, ASME, IMECE. His research focuses on application of data analytics and machine learning in manufacturing, supply chain, and healthcare. I request Professor to kindly address our participants.
Hello, everyone. Again, thank you so much for inviting me to be the session chair. I'm really excited to see what everybody is going to present and all the exciting research that is going to be discussed here. Good luck to all the presenters. Thank you.
Thank you, sir. Now we are moving towards the first presentation of the day. For the first presentation, I would like to call Monica for the paper title, A Soft Actor Critic Approach for Energy Management in Microgrids. I request the presenter to kindly proceed with their presentation.
Thank you. I'm going to select. I'm not so sure if you can see my screen. Yeah.
Yes, ma'am. Your screen is visible to us. You can proceed.
Okay, perfect. Thank you so much. So good afternoon, chairs, ladies and gentlemen. My name is Mónica Alonso from the Department of Electrical Engineering in Universidad Carlos III de Madrid. And I'm going to give you a short presentation regarding a soft actor critic approach for energy management in microgrids. This is the index that we are going to follow along the presentation, and we are going to start with an introduction. All of you know, in the context of a smart grid, residential energy management has become a hotspot due to the uncertainty in renewable generation, variability of electricity prices, and uncertainty electrical vehicle behavior, including variability in arrival, departure time, and stochastic consumption. Most of the study in which we are going to use electrical vehicles consider this as a mobile load. However, it's very important to take into account the vehicle-to-grid operation mode. That is the case in which we are going to share the energy stored in electrical vehicle battery in order to supply some services to the power grid. Reinforcement learning techniques have shown great potential to solve sequential decision-making problems with large system state space in complex and dynamic environments, such as the one presented in this paper. The advantages offered by reinforcement learning-based techniques is that they rely on trial and error processes to decide on the next action to execute with the goal of maximizing long-term rewards. In this paper, we are going to use a soft autocritic algorithms to solve the energy management in microgrids. Now we are going to move to the energy management microgrid problem description, and in the last decades, the residential sector has faced new challenges, mainly due to the installation of PV units on rooftop, storage units, and electromobility to improve home efficiency and approach net zero energy buildings. All these technologies led residential consumers evolve into a new power grid agent known as prosumer, which can consume or generate energy. This paper considers a microgrid composed of some residential demands, PV units, battery energy storage units, and plug-in electrical vehicles. The EV electrical vehicles, are going to be used in both operation mode, grid to vehicle and vehicle to grid. The autocritic algorithm controls the charging and discharging process of energy store units, that is, the electrical vehicles and the storage units corresponding to PV production, Taking into account the uncertainty of PV production, electricity market price variability, and the electrical vehicle arrival departure times to from the installation. The soft autocritic objectives are twice. The first one is to minimize the energy cost, and the second one is minimize the anxiety cost, In order to prepare the energy management in microgrid, we are going to use a Markov decision process formulation, because this is the mathematical framework that helps the artificial intelligence system to make the decision. We are going to have some important issues. Let me check it, please. We are going to have the environment. We can see the state, and agents are going to decide about an action that change the environment, and this gives us some reward that we are going to move to the agent in order to know the impact of the action that they have decided. For that issue, we need to know, regarding the Markov decision process, some key concepts. The first one is the states that represent different situations or conditions in the environment. The second is the action that indicates the choices an agent can make in a given state. Once we know the state and we have an action, we have a transition model that defines the probability of moving from one state, for example, from state 0, 1 to state 0, state 0, 1 to state 0, 2, After a specific action. The reward function provides feedback to the agent, indicating the value of taking a particular action in a given state. The policy is the mapping from one state to another through an action that is something quite similar to this one, determining how the agent will behave in each state. A policy can be deterministic or stochastic. The value function estimates the long-term reward of being in a particular state or taking a particular action. This is very important for us because we are going to decide the optimal policy, that is the policy that maximizes the expected discount reward, finding the best way to navigate in the environment, regarding this value function and the rewards. If we check the literature, we can find a lot of different options for the action space, for the rewards, and the reinforcement learning algorithm. We are going to see which is the action space that we are going to use in this paper, the reward, and as I told you before, we are going to use a soft autocritic algorithm to solve the energy management in microgrids. Here we have the state space in the upper table. Okay, we are going to have a flag in order to know if the electrical vehicle is arrived at home. Okay, we need to know the arrival and departure time, and also the state of energy that we have in electrical vehicle battery when they arrive at home. Okay. Moreover, we need to know which is the expected electrical vehicle state of charge or state of energy at departure time, and also the state of energy of the battery energy storage units. Which is the action? The action space that we are going to consider in this energy management of microgrids are two. The first one is the charging action over the PV storage units, and the second one is the charging action over the electrical vehicles. In both cases, we are going to move in a range between -1 and 1. If we have positive action, then we are going to charge the batteries, the mobile or the non-mobile batteries, okay? And if we are working with an action in negative values, we are going to discharge our batteries. As I told you before, we need a transition function, okay? And we to move from one state to another one, okay? And here we have the transition function that we are using for electrical vehicles in the upper side, okay? And the battery energy storage units associated to PV production in the lower part. Moreover, we have the evolution in the state of energy in both storage units regarding the action that we are going to do. You are going to charge or discharge our storage units for a time slot. And what about the reward? Well, okay, in the reward, we are going to have two different rewards. We are going to combine them. The first one is the reward related to the cost of purchasing or selling electricity energy from the grids, and is represented as a function of the purchase energy and the energy prices. The second one is related to the range anxiety fear. Okay, this is the fear related to the customer anxiety due to the insufficient stored energy of the electrical vehicle battery at the departure time. The anxiety term is characterized as a cost proportional to the ratio of the electrical vehicle battery state of energy at the moment of the departure compared to the desired one. Now we are going to move to the case study, and for the energy management in microgrid, the sub-factor critic algorithm has been implemented in order to manage the energy stored in electrical vehicles and battery energy system of this residential microgrid. The microgrid is composed by several detached houses, some of them equipped with PV panels on the rooftop and battery energy storage units for the surplus PV, to store surplus PV production. The maximum capacity of this aggregated PV installation is 30 kilowatts peak, okay? And the aggregated energy storage system presents a 100 kilowatt hour capacity with a global charging discharging bidirectional rate of 25 kilowatts hour. We have considered 10 EVs in the microgrid. Each EV battery has a 24 kilowatts hour capacity and a level 2 bidirectional socket with charging discharging power of 7.5 kilowatts hour. It is considered a normal distribution for the arrival and departure time of electrical vehicle and also for the state of energy. Finally, real data for electricity prices, PV production, and residential demand are considered in the training process. All this information have been obtained by the Spanish TCO, okay? And we are going to use 6 months of data, 80 for training and 20% for validation. Here, when we try to train the sub-factor critic, we need to take into account several important issues or features. Here we have the figures representing the most important feature that we need to select. The first one is regarding the horizon, okay? The prediction horizon is critical for determining reforming learning action, okay? According to this figure, this paper considers a prediction horizon of 6 hours because it gives an objective function value in the path of 1 per unit, okay, and with a little band of between mass minus 0.1, and it is a trade-off between the minimization of the objective function and the observation space dimension. Okay, In this second figure, we are going to try to determine the anxiety constant. Okay, the effect of range anxiety by means of the anxiety constant in EV battery state of charge or state of energy level at departure time is plotted in this figure. In this work, we are going to consider a constant of 3 in order to ensure that the battery is charged at the departure time without penalizing the sale of energy stored during V2G action. Finally, at the bottom of the slide, we have a figure that shows the state of the soft autocritic convergence by means of the episodic reward evolution. The solid green curve represents the mean value, and the steady zone represents the maximum and minimum values obtained. It is important to highlight that the convergence of the episodic reward has reached up to 500,000 steps. Now we are going to move to the results of the energy management in microgrids, and these figures show the charging-discharging schedule of the aggregated battery energy storage units and also the electrical vehicles. In the upper figure, the red line shows the evolution of energy prices during 4 days of the test process. Okay, the green and violet columns show the aggregated energy storage in the battery energy storage units and the electrical vehicles while plugged into the socket. It can be noted that battery energy storage units store the surplus PV production, and to reduce customer bills, energy stored in battery energy storage system and electrical vehicles feeds the residential demand from 7 to 9 at night when electricity prices are typically higher. In the second figure, the aggregated PV production and battery energy storage unit charge-discharge process is shown, okay? The aggregated PV production is in green, okay? Is in black, excuse me, and green represent the evolution of battery energy storage units, okay? It can be seen that these second units, okay, the battery, are charged during sunlight and discharged when there is no PV production to deal with residential demand during hours with higher electricity prices. According to this figure, the battery energy storage system minimum state of edge energy is reached daily. However, it can be seen that it's not possible in the days that we can see in this slide, the fully charged. Okay. Finally, we are going to move again to the first figure because here the violet line represents the charge and discharge of electrical vehicle. Okay. Excuse me. And in the bottom one, we have the charge and discharge ratio of aggregated electrical vehicle. Okay, it can be shown that electrical vehicles discharge at the minimum socket ratio as soon as they arrive home. But however, in order to feed, we are going to discharge at the maximum ratio in order to feed the residential demand, okay, and reduce the customer energy cost. And the electrical vehicle charging process occurs between 1 and 6 at night.
Mom, but you have 1 minute to conclude.
Okay, so this is the last one. The charging process starts with 30% of the maximum socket ratio and yet with a full socket ratio. Here we have a comparison with other algorithms used to find the charging-discharging optimal schedule for energy management in microgrid, and we can see that the soft autocritic is the one with the cost, with the minimum, the lower cost compared with the other one. And finally, I move to the conclusion. And in this presentation, we try to introduce a smart energy management strategy for a residential microgrid that is integrates 2 types of energy storage units: the stationary regarding the PV production, okay, and the electrical vehicle with both modes of operation. An exchange reinforcement learning algorithm solution using the soft autocritic is developed to optimize the charging and discharging schedule of these battery energy storage units as electrical vehicles. The soft autocritic algorithm is particularly suitable due to its ability to handle continuous action space and high-dimensional decision environment, such as the one we are focused on this paper. The proposed approach effectively manages uncertainties arising from stochastic PV production, time-varying electricity prices, and variable EV behavior. It minimizes the total energy cost while maintaining user satisfaction by addressing EV drivers' range anxiety in a stochastic framework. Finally, the flexibility of the method allows to adapt to varying number of electrical vehicles with diverse connection, disconnection times, state of energy at arrival, and required state of energy at departure, making it highly applicable to real-world microgrid scenarios. Thank you so much.
Thank you, ma'am. I request questions here, sir. Sir, do you have any questions?
No question from my side because this is on my area of research. Sorry.
Vishnu,
Okay,
sir?
I have just one question. Yeah. So you mentioned about the driver's anxiety. So how does that integrate into the reward function?
Excuse me, can you repeat because I have a problem with the audio?
Oh, so I was just asking, how does the driver's anxiety factor
Yes.
into that reward mechanism?
Yes, we use this because it is very important, the range anxiety constant factor, because depending on the value that we have, we can implement the vehicle 2G operation mode or not, okay? We need to look for a trade-off between the two modes of operation for electrical vehicles, okay? And we need to these two modes, the charging and discharging, but also we would like to have the electrical vehicle battery fully charged at the departure time, okay? If we have a big constant for this range anxiety cost, then we are not going to participate in vehicle to grid mode, okay? Because we are focusing on fully charged the electrical vehicles. Otherwise, if we are using a lower and a small constant for this range anxiety cost, we are going to promote the V2G mode instead of reducing the possibility to have fully charged the electrical vehicle battery at the departure time. For that issue, it's very important to look for the optimal parameter for this range anxiety constant.
Okay, okay. I think in the interest of time, I just would like to conclude. Thank you.
Okay, thank you so much.
Thank you, everyone. I have a request to all the participants to kindly adhere to the time slots. It's 12 minutes for the presentation and 3 minutes for question answer. On 10 minutes, I will raise a gentle reminder. Thank you, everyone. Now, I would like to call Mohammad Al Zafar Khan for the paper title Achieving Optimal Tissue Repair through MARL with Reward Shaping and Curriculum Learning. I request the presenter to kindly proceed with their presentation.
Hey, good morning, everyone. I hope I'm audible. If I'm not, please stop me. Apologies, I couldn't put my camera on because I'm having some problems. But yeah, I'll try my best, right? Just let me know when you can see my screen.
Yes, sir, your screen is visible to us. You can proceed.
Okay, thank you so much for this opportunity to speak here. And essentially, as indicated, it's achieving optimal tissue repair through multi-agent reinforcement learning with reward shaping and curriculum learning. Right. So I'm based at Zayed University in the UAE, Abu Dhabi. So just the outline of the talk, briefly, we're going to discuss the motivation for the approach. We're going to talk about the approach itself. Essentially, this entails multi-agentic mathematical modeling, then the need for reward shaping and curriculum learning. We're going to look at some experiments in silico, and we're going to conclude and look at some future directions. So just to mention something, the 5 themes that you see here, it does not necessarily affect the naming convention used in the slides. It's simply to provide an outline, right? So let's look at the motivation behind the study, right? In the future of medicine, both clinical and surgical, it will involve the gross use of AI technologies, right? These include 3D printing of organs, lab-grown organs, as you know from the famous Vacanti mouse experiment, where a piece of cartilage in the shape of a human ear was grown on the back of a mouse, and nanorobotics, which will be ingested through inoculation or injection, and it will be used to perform repair inside histological systems in the human body, right? That's the motivation for the study. How do we control, manipulate, and ensure that these agents complete the required repairs optimally, right? So why MAL? Why multi-agent reinforcement learning, right? As you might have seen if you follow AI news, right? Reinforcement learning is the driving force behind many successes in AI, right? Starting with AlphaGo, AlphaZero, going on to AlphaFold for DNA, which Demis Hassibis won the Nobel Prize in Chemistry for, and now with LLMs, with reinforcement learning with human feedback. And now the latest breakthroughs are with something called Alpha Evolve, released by DeepMind, in which they solve frontier math problems such as matrix multiplication, packing problems, and even proof-based in pure maths, right? So it's highly likely that when we do achieve AGI, reinforcement learning will have some contribution, right? Now, from a biological point of view, billions of cells need to work together cooperatively in order to do repairs in a human body, right? The reward function needs to be strategically structured because biological tissue repair involves complex, multi-scale, and often sparse feedback signals that are difficult for single agent-based reinforcement learning, right? It also accelerates the learning process by providing more informative and frequent feedback, right? In a biologically inspired reward function, right? You can see here this X with the subscript INJ, which denotes the coordinates of the injury site. The betas are just waiting parameters, right? The first term is the external rewards. The second term is the chemical cooperation reward signal. And the third term, which promotes gradient following. And the third term is the neural synchronization reward that promotes coordinated firing among the neurons, right? In the curriculum learning equation here, we see that this calligraphic T is the target value that the agent wants to learn. And T0 is the initial curriculum that they know, and TF is the curriculum that they want to achieve. And N here is just the number of iterations that you run for, right? Reward shaping makes sense because if, for example, your favorite beverage is a chocolate milkshake, right, you would attach a greater mental and dopamine secreting satisfactory reward of drinking a chocolate milkshake over drinking herbal tea, right? In a similar vein, a sentient being also learns skills gradually, right? Think about college, right? You start off with basic algebra and arithmetic before you can tackle vector calculus, right? So this gives like a sort of motivation for why these two. Now let's move on to the approach that we took, right? So the agents in our system include engineered cells, right? These include fibroblasts, macrophages, endothelial cells, and stem cells, or nanobots, right? The states are the localized molecular concentrations and the internal health metrics at the repair sites. The actions that the agents take include secreting repair factors, moving towards repair sites, and amplifying signals, right? We'll talk about the amplification of signals as we proceed to the next slide, right? The reward function now, it's a bit of a tricky one, right? So essentially, it involves biochemical signals such as adenosine triphosphate, the famous ATP, and also isopropyl beta D1 thiogalactopyranoside, right? IPTG, used to cause conformal changes by binding to the lac repressor proteins, right? Now let's talk about the mechanisms that we used in order to train, right? So we took into account three modalities. One is diffusion-based signaling, right? The concentration of molecular species I, denoted by Ci. The boldface X is the position vector of the location. Time at time slice T. D is the diffusion coefficient. Lambda is the concentration decay. And S is the secretion term, right? And eta is the spatio-temporal noise term, which essentially, if you try to do an average of it, you get out Dirac delta functions that are separated in terms of space and time, right? We borrowed this rationale coming from statistical physics, right? And the motivation behind this is a very famous paper that Alan Turing wrote about the chemical basis of morphogenesis, and also more recent work by Alf Dauncey and Ehrenberg on the mesoscopic reaction diffusion in intracellular signaling. Now, the synaptic or electrochemical neural-like signaling, we borrowed this idea from very famous ideas in computational neuroscience, namely the Hodgkin-Huxley model, the Wilson-Cohen model for rate-based neurons, the various connectionist-based models, such as the artificial neural networks that we all know and love, and also Hebbian learning theory, right? Lastly, the stochastic noise. In the human body, there's always like heat fluctuations, there's randomness, the stochasticity. So basically, this makes sense to include such a term, right? Moving on into the approach that we used. So this is the algorithm that we designed. It's very complex, so I'm not going to take you line by line, but I'm just going to give you a brief outline of how it works, right? So for each time step, the concentration can be solved using some numerical scheme like an implicit Euler or something like that. And for each agent, the new state is observed with which is dependent on the current concentration concatenated to some health metrics, right? These health metrics include the localized ATP concentration, because biological agents prioritize repairs in regions with high ATP concentration. The other one is the repair factor secretion rate that tracks the vascular endothelial growth factor production and the coherence of the neural activity, which measures the synchronization. Right thereafter, the agent's actions are sampled from a stochastically perturbed policy distribution, and signals are transmitted between neighbors. Right, once the input signal is received, the reward function is computed. Thereafter, the policies are updated using some kind of policy gradient method, which is regularized using information entropy, which encourages exploration amongst the agents, and the weights are updated using a Hebbian learning rule, right? Lastly, the curriculum is updated, and once the maximum number of steps is reached, the trained policies and the final concentrations are produced, right? So in our experiments, I'm not going to read out this because it makes no sense to read out values, which you can just look up. But I'm just going to put it here for all intents and purposes. More interesting is the results that we got from the experiments, right? So using just 10 agents, right? If you look at this first graph, and specifically moving to the graph on the top left, we see that the shifting chemical gradient peaks over time, confirming the expected diffusion decay behavior of the signaling equation, right? This shows how the agents actively release molecules that guide movement. Next, if you move to the top right, right, we see the spatial distribution of the agents. These smooth multimodal curves arise from the stochastic policy sampling, where the agents specialize by committing to different areas, particularly near high gradient zones, which likely represent the injury sites. In the bottom left, right, we track the alignment between the chemical signal peaks and the moving target over time. The agents successfully follow these moving signals, demonstrating how chemical gradients serve as dynamic rewards to guide them through repair regions. And in the bottom right, we see a heat map, right, that captures the evolution of the chemical concentration across space and time, visualized as a diagonal bright band, right? You can see it's going from here to here. This confirms the chemical migration prediction by our stochastic PDE and reflects the progression of the learning curriculum, right? Now, if you move on to the reinforcement learning, multi-agent reinforcement learning parameters, right? In the top left, we see increasing agents diversity over time suggests that there's role specialization, right? This erraticity that you see here is just the stochastic noise that we sampled, right? The top middle, we see the inverse relation between entropy and reward, reflects that the policy is converging. In the top right, we see the stabilization of the rewards despite ongoing noise, indicating robust policy learning. In the bottom left, we see a uniform state visit pattern, which show full spatial exploration. This is akin to how immune cells survey tissue in the human body. In the bottom middle, we see neural weight stabilization reflects steady learning, similar to synaptic consolidation. And in the bottom right, we see the Q value evolution shows early overestimation followed by correction. This mirrors how biological systems temper overreactions as feedback accumulates. Right? Lastly, we see the collective molecular secretions, right? And we see also we see the collective molecular secretions, and oh, sorry, what did happen here? Sorry, we see the collective molecular secretions, and we see the curriculum, right? So this mimics how the agents should learn, right? Essentially, you should learn with like very minimalistic amount of information, and as you get better, the agents must specialize more and be able to perform the reward in a better time, right? Speaking about the collective secretions, we chose an exponentially decaying secretion function. This makes sense biologically because initially you start off with high concentrations, and as the agents deteriorate in their like life or in their lifetime, meaning they begin to die or you dissolve them, or the sorry or the or the agent has to maybe like let out some bodily fluid or something, these things get secreted, right? So that profile makes sense. Now let's talk about the limitations of the study, right? So as with any study, it's not without limitations, right? All the experiments that you see that were performed are in silico, right? Meaning they were performed on a computer, but we need wet lab verification of them, meaning we need in vivo experimentation, right? To perform this on a human some person, right? The models are chosen, we believe, are too simplistic, right? They're like toy models and may not accurately reflect the stochastic nature of the human body. The experiments were done with just 10 agents, right? Whereas in the real world histological systems, possibly millions to billions of cells are involved in the repair process, right? So we need to look at how, as the number of agents increase, what is the behavior of the system. Lastly is the credit assignment problem, which is very famous in reinforcement learning. specifically the temporal credit assignment problem. And this entails knowing which agents performed a particular repair at a site, right? Now, the extensions of this work, we've seen that this method that we showed is relatively effective, right? We got decent results on the pilot experiment. Extensions of this work include 3D tissue scaffolds that incorporate like biological and mechanical, which we call mechanobiological cues, more realistic model of the dynamics to address the credit assignment problem. So that's also one of our goals. And then, as we indicated, to investigate the large scale behavior as n becomes very large. And yeah, I say thank you for your attention. I know I rushed a bit, just to end on a light note, because we were talking about concentration gradients. I put the QR codes to have these concentration gradients here. So if you want to read the paper, please scan this, or if you want to reach out, or our group is very open to collaboration and listening to ideas. So you can contact me like that. And thank you very much.
And thank you. It's a nice presentation. Am I audible to you?
Yes, I can hear you. I just want to stop sharing my screen if I figure out how to.
Yeah, it's a very nice topic. AlphaFold is also doing the same, I think. I just want to know that what data set actually you are using.
So with reinforcement learning, there's no data set, right? So the agent makes its own data by sampling the environment. So yeah, there's no data. We just train the agent. The agent learns through the dynamics of the reaction diffusion equation, and it interacts with the environment. Then when the neurons fire in the cells, that gives it like some kind of indication of which direction to move and how to move towards the repair site. When they perform a repair, they secrete like some kind of hormone or chemical that tells the human observer that the repair has been done on the site.
But how the accuracy will be maintained later?
I'm sorry, I never get that.
How the accuracy will be maintained later?
Later, okay. So the accuracy, so as we said, like these are computer-based experiments performed with like 10 agents, so we got good results, but we aware that, like in the human body, like we don't know. So one of the, like, as the number of agents increase and there's randomness in the environment, we don't know what will happen. But one of the strategies that I proposed, and it's like a Neurops kind of idea, was to investigate this as a mean field game. So with the mean field game, what happens is as the number of agents become very large, you take that as an average, and then you take the current agents that you're modeling your system with, and you sample from that average. And when you sample from that average, you can sort of get a holistic behavior of how the agents would behave and how the accuracy would look.
Okay, thank you. Nice work it is. All the best.
Thank you,
Thank you
sir.
so much.
I request Vishnu sir. Sir, do you have any questions?
Yeah, just just a quick question. So you're so your title, it says achieving optimal tissue repair, right? So what kind of repair strategies did your agent learn?
So it learned essentially like even a histological system, like meaning the internal body kind of thing, like organ inside the body is like injured or something. So it goes towards the repair site and it performs like cellular based repair. So it's not so these each agent performing one cell repair or multiple cell repairs, cumulatively you get the repair of the entire organ or the entire like whatever's inside that it's repairing, like a vascular kind of junction or something like that. Yeah.
Okay, all right.
Yeah.
Thank you.
I'll tell you briefly about this idea if I have like 1 minute. Yeah, this idea essentially came from like pop sci, right? Popular science. Like we see these things when you're kids that people take these robots go in the body and then they're able to kill these dead cells or cancer cells or whatever. So we believe that this is one of the futuristic surgical medical technologies, and that's how we sort of investigated this. But sorry for taking the time, man. Thank you.
Yeah, it's interesting. Thank you.
Thank you, sir. Thank you, sir. Now we are moving towards the next presentation. For the next presentation, I would like to call Aranta Atha for the paper title, Enhancing User Adoption of Digital Fuel Subsidy Systems Insight from the My Pachama app using QTAUT model. I request the presenter to kindly proceed with their presentation.
Thank you. Can everyone see my screen?
Yes, your screen is visible to us.
Yes.
Okay. Okay, hello, greetings to everyone. I'm going to presenting about my work with the title of Enhancing User Adoption of Digital Fuel Subsidy Systems, insight from My Pertamina app using the Taut model. And this work made by me, Arinta Atayakayana, and my co-author Chandiwan Chandiwan, and presented by me, Arinta Atayakayana. So in this presentation, I'm going to talk about the introduction, methodology, result, and in the end, there's a conclusion. Okay, so the first I'm going to introduce about My Pertamina. So what is My Pertamina application? The Internet of Things, or IoT, is growing quickly as we progress into the future, with intelligent devices seamlessly integrated into our everyday routines. Indonesia has also experienced rapid technological growth, especially in the use of information systems, and it is including on every sector. So My Pertamina application is an application that made by Pertamina, and My Pertamina is the one of the biggest oil and energy companies in Indonesia. Pertamina launched My Pertamina application to support fuel purchases and other services. And the app has become essential because it's a rule that made by the government for those buying subsidized fuels like diesel and pertalite. Users are required to register and use the app for these transactions. And because this is one of Pertamina's goals, which is distribution of subsidized fuel is more targeted. So what is the problem? And it can be causing the behavioral and adoption of the application. So there's a lot of articles, but I'm showing these two articles. And the first one is titled Subsidized Fuel Users in Nunukan Complain About Difficult Access to My Pertamina. And the second one is titled Some Consumer Fail to Access My Pertamina Consider a Headache. It means these issues make hard for Pertamina to meet its goals of improving digital transaction and ensuring fair distribution of subsidized fuel. And this research is important because it examines the factors that influence users' adoption of My Pertamina using Utah model. Okay, we're going to the methodology that this work is using Utah model. So Utah is unified theory of acceptance and use of technology, which is a model used to predict the acceptance and use of technology by users. So the respondent of this work, it contains 105 respondents that we got from online questionnaire by Google Form that we spread around Indonesia. And also this framework is a combination from previous study by Mensah and Khan and Hassan and Yasin. And the reason why we combine this framework because it's for the better testing. So there are 12 hypotheses and 10 variables. It begins with performance expectancy, effort expectancy, awareness, perceived financial cost, technological infrastructure support, government regulation, institutional privacy concerns, institutional source reliability, and all these factors influence behavioral intention to use, which ultimately leads to the adoption of the My Pertamina application. Okay, we're going to the result. So most of the respondents are male, and most of the respondents come from major city like Jakarta, Bogor, Semarang, and Surabaya, but also followed by several respondents from Bandung, Yogyakarta, Medan, Palembang, Pekanbaru, Banda Aceh, Padang, Bandar Lampung, Balikpapan, Banjarmasin, Makassar, Kupang, Cirebon, Subang, Payakumbuh City, Tasikmalaya, Sukabumi, and Grobogan. And this may explain that the higher adoption rates in urban areas compared to remote regions like Nunukan, where users often experience connectivity and registration difficulties. And most of the respondents' jobs are private employees. This was followed by respondents of the millennial generations, which means that most of respondents are people who already have a job. And additionally, most of the respondents have a bachelor's degree, so which showed that they are well educated and have a solid understanding about technology. Okay, so this work is processing the data using Smart PLS. The models got convergent validity is assessed using vector loadings, cron-based alpha, composite reliability, and average variance extracted. So the standard of factor loadings Chrome batch alpha and CR are more than 0.70. Meanwhile, AVE needs to be higher than the recommended value of 0.500. And in this result, it shows that loadings, Chrome batch alpha, CR, and AVE meets the required standard for reliability. Oh, wait. And in this one is discriminant validity by using hetero-trait mono-trait ratio of correlation, or HTMT. Its measured construct differ from each other. So this is if the HTMT value lower than 0.90, it means that discriminant validity is met. So it shows that the result of HTMT did not exceed the value of lower than 0.90, which means the discriminant validity was granted. Okay, now we're going to the result of the PET coefficient. From the 12 hypotheses, there are 6 hypotheses that show not significant impact, and 6 other hypotheses show significant impact. On the hypothesis 1, it had a significant result between performance expectancy on behavioral intention, which means all the respondents agree that the performance of the app met their expectation. Hypothesis 2 shows no significant result between effort expectancy on behavioral intention. However, this is explained by the characteristic of the respondent. Most users are already familiar with the digital application and mobile transaction. Hypothesis 3, awareness has no significant impact on behavioral intention. However, this lack of significance can be explained by differences in how familiar users are with the app. Hypothesis 4 shows no significant relationship between financial cost and behavioral intention because it's explained by the fact that most respondents did not perceive cost as a barrier. Hypothesis 5 shows the technological infrastructure support has no significant impact on behavioral intention. Means people still have trouble using My Pertamina, even though the technology is there, like when the internet is slow or keeps disconnecting or cannot access the application. Hypothesis 6 reveals that technological infrastructure support significantly impact adoption. It means that technology infrastructure plays a role in adoption. While there are challenges such as unstable connections, the number of respondents who agree with the existence of infrastructure is quite high. Hypothesis 7 indicates that technological infrastructure support significantly impacts performance expectancy. It means good technology infrastructure will contribute to performance expectation. Hypothesis 8 shows there is a significant result between government regulation on behavioral intention. It means government regulation influence usage intention. Hypothesis 9 shows no significant results between government regulations on adoption. However, this regulation only make people follow the instruction, not really want to use the app. Hypothesis 10 indicates that institutional privacy concerns have no significant impact on behavioral intention. However, even though users care about trusting the institution, they are more concerned about how well the app works in the practice. Hypothesis 11 demonstrates that institutional source reliability significantly impacts the behavioral intention. This means that respondents indicated trust in the institution managing the application increases their intention to use it. And the last one is hypothesis 12. Shows there is a significant result between behavioral intention on adoption. It means that the higher of the user intention, the greater the possibility of adoption. So the study findings are not all factors significantly influence the intention and adoption as in the previous study. Hypothesis 2, hypothesis 3, hypothesis 4, hypothesis 5, and hypothesis 9 and hypothesis 10 shows no significant result, which means that effort expectancy, awareness, perceived financial cost, technology infrastructure support towards intention to use, government regulation towards adoption, and institutional privacy concerns do not affect My Pertamina adoption. Users already find the app is easy to use and are aware of regulations and do not see cost as a burden. Infrastructure issues still exist but do not drive usage intention. Regulations drive compliance rather than adoption, and privacy concerns override functionality. However, Despite some hypotheses not significant, the research using the utility framework can still be considered successful because the model demonstrates good validity and reliability, and also several key factors. And also the last one is conclusion. So the conclusion is the study identifies key factors influencing the adoption of the My Pertamina application in Indonesia using youth-out model, emphasizing that performance expectation and the reliability of institutional sources are crucial determinants of behavioral intention, which in turn influence adoption. In this regard, enhancing app features to improve convenience and efficiency during the refilling process is essential. Additionally, clear and supportive governance regulations are needed to encourage broader adoption of the app. These findings provide valuable insight for stakeholders, including Pertamina and policymakers, while also encouraging users to actively provide feedback to increase their digital experience. By focusing on these aspects, My Pertamina app can increase the adoption. And thank you for the attention.
Arintha, how many papers you have studied for this study?
Sorry,
How many papers you have studied for this study?
how many papers? What?
How many research papers you have studied?
How 10?
Okay, okay. Thank you.
Yeah.
Thank you, sir. Vishnu, sir, do you have any questions?
Yes. So, who are the participants in your survey? Like, how did you select them?
Okay, so the participant is anyone in Indonesia who's using My Pertamina application as their daily for the transaction, the transaction of subsidies file.
Okay. Okay. So it's random, or do you have a specific target group like students or working professionals or senior citizen?
There's no specific, but only people in Indonesia that use this application.
Okay. Okay. All right. Thank you. That's all I have.
Okay, thank you.
Thank you, sir. Thank you, ma'am. Now we are moving towards the next presentation. For the next presentation, I'd like to call Gloria for the paper title From Structure to Experience, Designing the Front End of a Cultural Culinary Portal. I request the presenter to kindly proceed with their presentation.
Okay, good day, everyone.
Morning, ma'am.
Let me share my screen, okay? What? So everybody has seen my screen?
Yes, ma'am. Your screen is visible to us.
Okay, my name is Gloria Virginia. I'm going to present a result of our research. Wait. Okay, entitled From Structure to Experience, Designing the Front End of a Cultural Culinary Portal. This research is actually developed as a part of the larger Alun-Alun project. Alun-Alun project is a multi-year initiative focused on the semantic representation and digital dissemination of Indonesian cultural heritage, supported and funded by Indonesian government and our university. The project actually has resulted in several publicly available web-based knowledge portals that model cultural objects using semantic web standards like for temples, traditional games, traditional foods, batik, traditional dresses, and etc. So there are so many, you can see it from here. And then, and because it is a semantic web with the ontology, so it allows us to connect, the ontology connects each other as visualized here. So this particular study is a continuation of the work by CDIC. So it is one of the semantic web that we have, which focus on developing ontologies and implementing them within a semantic web framework for representing the traditional food knowledge. Also, CDIC's knowledge-based web system is effective in presenting the structured content in the form of ontology. Users reported that navigation very difficulties and semantic ambiguity is there while they are having interaction with it. So while CDIC work emphasized back-end semantic modeling using all RDF and onto-knowledge methodology, the present study focused on the front end, specifically the user interaction and experiences aspect of the cultural culinary catalog web application. So we intend to build a bridge between the semantic representation and the interface level design rooted in the user cognition and participatory methods by applying the human-centered techniques like user-centered design for the methodology, as well as some other tools like tree testing and card sorting to restructure the web content, to improve the navigation, and hopefully it will enhance the user comprehension. Okay, so from the cognitive science perspective, cultural knowledge is stored not only in artifacts, but also within the shared cognitive models. So cultural schemas guide how individuals perceive, interpret, remember the knowledge. Therefore, digital platforms that aim to present the cultural data must consider cognitive load, concept grouping, and memory retention. That's why we applied the user-centered design framework, which is a human-centered technique, because it answers the design development aligned with the user needs and expectations. This is our research flow diagram. So we adopt the UCD methodology and place the users at the core of each development phase. Okay, so this is the first phase of the UCD. We use the 20 respondents and we do the interview to them. The respondent age 16 to 49 years old, and they're able to operate the computer proficiency and etc. So the insight from the interview is we got the user experiences and expectations. And then the second phase, we use the tree testing tool to evaluate how well users can navigate and locate information within existing site structure. And then we use the metric like task score, success rate, directness, and time spent. And then we also use the card sorting tool to reveal the user preferred groupings of content, informing the information hierarchy and also the labeling system. Okay, so from there, it provides the concrete user requirements for us to give us the guide to develop the more intuitive and usable interface. Okay, now the third phase, produce design solution, we create the wireframe, the mock-up, and the prototype. And then we evaluate all of them using online surveys, user interviews, and also the usability testing. So from there, insight from each evaluation stage guide us to improve the next iteration. So the implementation, we implement the prototype using the HTML, CSS, and JavaScript in a Visual Studio Code environment. And then we apply the information architecture components. So the first thing is the organizing system. We organize the information based on its topic, and then we use the top-down approach to create the hierarchy like this one. And then for the labeling system, we focus on the headings of each sections and also the navigation systems. We try to use the consistent label for each section. And then for the navigation system, we use the global navigation, also the table of content. So this is the navigation bar for the global navigation and also the footer. And then this one is the table of content. And then the fourth is the search system. We designed the search or browsing interface for the website. So this is the search system, but actually in this study, we didn't develop a search system algorithm. So because this is only the design. So for the final testing, we use the Google Lighthouse testing. It helped us to give a report that consists of 5 metrics like the performance, the accessibility, best practices, SEO, and the PWA. This is the progressive web application. So you can see from here the score for the performance, accessibility, and best practices, and SEO. And you can see here it's enabled because we don't use the PWA. Okay, and the last one, we use the system usability scale. So we gave this kind of questionnaire to our respondents, and we got the 85.5 score, which is categorized as A, as excellent. So the conclusion, the user-centered redesign of a traditional Indonesian culinary portal has been made, and then significant improvements in usability, navigation, and content structure. We achieved the excellent usability score, and this project support cultural preservation through clear information architecture and user-friendly design. For the future studies, we should develop full semantic search with NLP and ontology, like I mentioned before, because we only design the interface, but not the algorithm for the search engine, for example. And then we need to expand the multilingual support for regional languages because we have like 500 something languages, traditional languages in Indonesia. And then implement the automated content verification and knowledge acquisition. So there will be, so we don't have to acquire the knowledge manually again, like now, like before that we did while we are developing the ontology. And then the last one, we need to extend to other cultural domains. We still have a lot of cultural objects. For example, like wayang, that's the most
Sorry to interrupt,
known
ma'am,
thing.
but you have 2
Yes.
minutes to conclude.
So this is the last slide of mine. Thank you.
Thank you, ma'am. I request session chair, sir. Sir, do you have any questions?
No question from my side, but Karthik, there is a query from Professor Dreamtree. I think he is asking for some sequence of talks. If you please provide it to him, it would be great.
I
And
request
thank you, ma'am.
to kindly send a message in my personal chat box. I'll try to help him out. Thank you.
Thank you. Thank you, ma'am, for your nice presentation.
I have
Thank you.
just,
Uh,
so did you completed your design and prototype on the Figma? If
Pardon?
so, it will be great. It will be great if you show us the demo on the Figma
Figma?
design prototype. Yeah,
Oh,
you did
wait.
it in Figma. You said that.
Yes. Wait. Oh, I don't have it because my friend didn't give me. Actually, it's about a year ago, so I don't have it anymore here.
Yeah. So thank you so much.
So sorry.
Thank you, sir.
That's okay. That's okay. You're welcome.
Okay, thank you.
Thank you, everyone.
Thank you so much.
Now we are moving towards the next presentation. For the next presentation, I would like to call Shaheen for the paper title, Human AI Collaboration for Rescue Missions, a Reinforcement Learning Approach in VR Environment. I request the presenter to kindly proceed with their presentation.
So, hello everyone. Can you see my screen?
Yes, sir, your screen is visible. You can proceed.
Perfect. Okay. Hi everyone. My name is Shaheen Durudian from University of North Carolina at Charlotte. This is my presentation of my research on optimizing rescue mission strategies, where I'm integrating human intuition with AI efficiency in VR simulations by kind of using reinforcement learning in this scenario. So the idea of using VR headsets for training came from the abundant evidence suggested that the limitation in cognition and ineffective communication and poor decision making, and it all caused high risks and resulted in huge casualties. According to U.S. Fire Administration, there were 1,900 fires which caused around 2,700 deaths and around 600 injuries, and it also caused 230 million loss between 2018 and 2022. The problem we were trying to address at that time was, focusing on poor decision making during a SAR mission, especially when there was a house on fire and there were people trapped inside. So to solve that problem, we created a platform to use VR to train firefighters in a virtual environment. The idea was to send in the trainees into this virtual house where there was a fire and a smoke, and there were also people trapped inside. The trainees walked into this environment while wearing the headset and having the two controllers on each hand. And they were asked to navigate through the fire and the smoke to rescue as many people as they could. And, were provided a live map which showed them the live location of the people inside the house, and also the live location of the fire and smoke where they were navigating through the environment. So you can see the map here in this picture. And the reason there are two maps is because the users were being trained in a two-story building scenario. So there were two maps for each floor. So yeah, the players were given the map, and on that map they could see where the fire and also where the people are located inside the house. Then while the users were trained in this environment, we recorded the data from headsets and the virtual environment, so that at the end we could calculate the performance of each trainee. So if you go back to the training environment, you can see the player has the map, and by using that map, they were able to see where the people are located and where the fire is located also inside the environment. Using that map, they had to decide who to rescue first and in what order. they had to decide whether to rescue the person closest to them, or also decide to rescue the person who is far away but in danger, who are closer to fire spots. Also, to provide users with more information, we had a trajectory on the floor to show the path to the closest people. But by showing the trajectory on the floor, we are not, forcing the participant to follow that path, but it was up to them to decide which path to take and, decide which person to rescue first. But with this study, we had two problems. First, even though the users were provided with real-time information, that still didn't mean they could rescue everyone in the shortest time. And the second problem was we had no candid data to compare the user's performance with. We did have each user's data to compare to each other, but we didn't know how they perform compared to a candid data, which takes us here. How could we make it better? How in terms of better compilation time and also better accuracy? And by that, by compilation time, I mean finishing mission before the fire gets to the people who are inside the house, and better accuracy can be led to more people being rescued inside that house. So we decided to use AI, or better say, reinforcement learning to compare the user's performance. And if we could map this problem to an MVP, it means we could run RL algorithm on it and hopefully solve this problem. Because if you can map your problem into this framework, then actually you can feed it into reinforcement learning algorithms that can try to solve it for you. The goal then, of course, for that algorithm, the reinforcement algorithm, will be to find a policy to maximize the expected rewards, discounted rewards, or I would better say discounted rewards over time. If we can get that point to fit this environment into reinforcement learning, we can generate the expected rewards for each state and action. We can eventually find the shortest path, and if we do follow the shortest path in this case, we are if you don't follow that shortest path in this situation, we are wasting time and also resources. So how reinforcement learning solves our problem? We try to use Q values, and you might ask what Q values are. Q values are the weights or values of each state, or in another term, the sum of discounted rewards when starting from the state S and acting optimally. And there are generally two ways to calculate the Q values. As you know, we can use a table to restore all the generated values, but that might take a lot of space and time to evaluate. But for a huge environment like a three flat building, and when you have limited time to decide which path to take, it would be impossible to store all the Q values in a table, because it would need a huge amount of memory. The agent would also need many more episodes to learn about the environment. So as a solution, we can use deep neural networks to approximate the Q value functions. Since we all know DNNs or deep neural networks are known for the efficiency for approximate functions. Here's the design setup of the whole study. We have a virtual environment which is being used as a training platform, and you can see the square grids inside and around the house. This is also generated inside Unity. This environment contains almost every element of the house. And to have a better top view, I removed the ceilings of the environment so you can see what's going on inside the house. The orange arrow shows what we did in the previous paper. We designed a virtual environment, and we can use this to send in trainees and record the data while they're doing the rescue mission. The green arrow, on the other hand, is what we are proposing. We map the same virtual environment into a grid board using those square grids I showed you on the first, green environment. After we have the initial parameters, we'll then run the RL algorithm, which will generate the path from the start point to the person inside the house. We will then send the optimized path back to the virtual environment, which is Unity, and send the AI agent inside the environment and ask the agent to follow that path. And with that, we can record the data, but this time from the agent's perspective. After we have the data from both the user and the agent, we can compare and see how the user performance was inside that training environment. And by that, I mean, did the user performance make sense compared to the agent? Did they make the right decision in the rescue process? Did they pay attention to the danger level of the fire inside the house? So here's a video to show how the AI agent utilizes the optimized paths generated from the RL code with the small fire. Just for demonstration purposes, I removed the ceiling again just for you to see what's going on inside. And this is also running the algorithm in a small section of the house, not the entire house, not the entire two-floor building. Real quick, just to see what we did before we get here, we mapped the mesh grid of this section of the house and ran the RL algorithm on it to generate the path. You can see how it looks on the left side in the grids. And once we have that path, we then load that path into Unity, which is our training environment on the left side, and ask the agent to follow that path. And we recorded the data while the agent was performing the rescue mission. So once we load the path into the training environment, you can see the green path, which is our trajectory. The agent follows that path and rescues people inside that house. Here is the same thing happening, but instead of small fire spots, we have medium fire spot. You can see the fire in the house is larger, which means more danger. Again, the agent is trying to navigate the path and rescue the person, but this time moves further to the left and hits the wall because the agent is trying to avoid the fire on the right side of the inside the environment. So to the next slide. Here are some results by comparing the agent to the.
But you have 2 minutes to conclude.
Thank you so much. So the environment setup for both studies were exactly the same, which is expected. The results are promising. You can see in the box plot the total time it took for the agent to finish each run is in general 21% less compared to the users who did the same study. This kind of answers our first research question: how can we improve rescue strategies? We are able to, decrease the mission time by almost 21%. Total rescue percent, this plot shows how many people got rescued in each run compared to the users who did the same study. Again, the AI agent was able to rescue more people, actually 16% increase in the rescue rate. And I'm sure by using neural network, we are getting better results in moving distance. But something to consider is that the agent sometimes moves an extra distance to rescue more people, which makes sense. If there are more people to rescue, the moving distance will, increase to get to that extra person. So it is expected to have an increase in the walking distance if the agent rescue more people, but still the agent came close to the user's performance, even though the agent walked more and rescued more people inside the house. Task duration, this shows how long it took for each participant to complete the run, to complete the study, considering the danger level of the fire, almost 10% better performance and faster reaction time. So this is the last slide. But by combining these items discussed in this presentation, we'll have a virtual firefighting training platform where trainees' performance is evaluated and assessed against candidate data. We can evaluate and assess trainees' performance. We can, we can get better results in SAR training platform and can be adapted for multi-users training environment. This can also be modified for continuous dynamic environment as well. Thank you so much for listening to my presentation. If there is any question or suggestion or ideas, I would happily take them.
Thank you, presenter. I request session chair, sir. Sir, do you have any questions?
No, we can move to the next presentation, please, if there is no question. Thank you.
Okay, sir.
Yeah, I have a question. So what hazards did your simulation consider? Is it just fire hazards, or it look for some other environment related, some
So there are
issues?
multiple, there are multiple parameters that we consider in this environment. It wasn't, the time was not enough for me to go over and cover everything. The most important two parameters we have is fire danger, the fire level, and also the smoke level inside the house. But the other things that we consider is if someone who is trapped inside the house is close to a fire spot, their life is more in danger. So it makes sense for people to rescue those people first. But the AI would know which persons are close to the fire spot. So while training, will notify the people inside the house that those people on the second floor or on the third floor are closer to fire. So it makes sense for them to make to rescue them first. But it wasn't enough time for me to go over all those. But yeah, we have multiple parameters inside the house to consider. Yes.
Okay. All right. Thank you.
Thank you, sir. Thank you, sir. Now we are moving towards the next presentation. For the next presentation, I would like to call Yujin Shao for the paper title Improving Alzheimer's Disease and Related Dementia Phenotyping in Electronic Medical Records through Transfer Learning. I request the presenter to kindly proceed with their presentation.
Thank you. Let me share my screen. Okay. All right. Can you see my screen?
Yes, sir. Your screen is visible to us. You can proceed.
Okay, thank you. So, hi everyone. My name is Yijun Xiao. I'm an associate research professor from George Washington University. So I'll be presenting our study on improving Alzheimer's disease and related dementias phenotyping in electronic health records through transfer learning. So Alzheimer's disease and related dementias, or ADRD, is a basket of diagnoses including dementia due to Alzheimer's disease and dementias of other types such as vascular dementia. ADRD affects millions of people globally, leading to cognitive decline in those people. As the global population is aging, ADRD is causing increased caregiver burden and rising healthcare costs. All these issues underscore the urgent need to identify and implement effective prevention and treatment strategies, which further rely on accurate ADRD phenotyping. In this study, ADRD phenotyping refers to identifying ADRD patients using electronic health records or EHR data. Traditionally, ADRD is identified in EHR using ICD codes. However, ICD codes for ADRD diagnosis are known to be inaccurate. For example, one study reported that the sensitivity and specificity of ADRD ICD codes were about 85% and 89% for dementia and 64% and 95% for Alzheimer's disease, respectively. So our approach for ADRD phenotyping is to build a deep neural network model to predict the ADRD status. The ADRD status used two labels, yes and no. The DNN model uses our latest developed DNN architecture called Hybrid Value Aware Transformer, or HVAT. This architecture is based on Transformer, which is also the foundation for today's popular large language models such as ChatGPT. This model takes longitudinal and non-longitudinal data as input, and it outputs ADRD risk scores, which are values between 0 and 1. For model training, we used transfer learning. The transfer learning is also a popular technique behind the large language models. Transfer learning has two stages of training. The first stage is called pre-training, in which we train the model on a very large dataset with labels that can be obtained with a very low cost. However, the labels may be very noisy. And the second stage is called fine-tuning, in which we continue the training of the pre-trained model on a smaller dataset with labels of high accuracy, but the cost of the labels may be high. For pre-training, the data source is the United States Veterans EHR data from the VA department. The labels are the ADRD status created based on the ICD codes. So the cost of these labels is very low. But as we mentioned earlier, the accuracy of ICD codes is not good. Therefore, we may call the labels silver standard. In our cohort, we have 50,000 cases and 50,000 controls. We use the features including the non-longitudinal ones, age, sex, race, ethnicity, and the longitudinal ones, comorbidities, medications, procedures, note titles, and topics in the notes from the 5-year-long history ending on the index date. For fine-tuning, we used a cohort of 1,200 veterans without ADRD ICD codes. The labels are the ADRD status determined by human experts through chart review. These labels are more accurate than ICD codes. Therefore, we call them gold standard. However, the cost of these labels is very high because it comes from human chart review. The features we used are the same as those from the pre-training stage. For evaluation, we used tenfold cross-validation. So this figure summarizes the transfer learning strategy. So on the left side is the pre-training stage. The DNA model is trained on a large dataset with labels being the ADRD status from ICD codes. Then this pre-trained model is transferred to the right side and further trained on a small dataset with labels being the ADRD status from manual chart review. Now here are the model evaluation results. For comparison purpose, we also trained and evaluated several other models using different training strategies. The first model is the main product of the study, which has gone through the 2 stages of training, pre-training and fine-tuning. So it achieved an AUC of 83.2%, which is the best of all the models. If we only do pre-training but not fine-tuning, then the AUC dropped to 81.5%. So that is the second model. If we don't do pre-training but only train from scratch on the 1,200 veterans data, then the DNA model achieved an AUC of 76.8%. And this is the third model. And the last model is a linear SVM model, which was only trained on the 1,200 veterans data. And it achieved the lowest AUC, 74.5%. So this shows that DNA model is better than other traditional models like linear SVM model. And the pre-training and fine-tuning are both necessary for accurate prediction of ADRD status. Now, to further validate our main product model, we performed a survival analysis. So we first randomly selected 2,000 veterans for each year from 2009 to 2018. So in total, we have 20,000 patients. For each patient, we define an index date, which is the date of the last encounter in their selection year. And the final cohort are the 16,943 veterans without ADRD ICD codes by their index date. Then we applied the fine-tuned DNA model to the final cohort and calculated the ADRD risk scores. The scores are all values between 0 and 1. Then we stratified the cohort into 10 equally sized groups called deciles. Finally, we plot the Kaplan-Meier curves showing ADRD-free survival by the ADRD risk decile groups. And this is the plot of the Kaplan-Meier curves. So for the first quantile of veterans who have the lowest ADRD risk scores predicted by the HVAD model, the corresponding curve shows the highest survival rate. At the other end, for the 10th quantile of veterans who have the highest ADRD risk scores predicted by the HVAD model, the corresponding curve shows this group has the lowest survival rate. And the other curves are in the middle, and they are ranked in the same order as the quantile order. So therefore, this provides a prospective validation for the ADRD phenotyping. So for discussion, we would like to emphasize that accurate ADRD phenotyping is important for many ADRD-related studies, and phenotyping through transfer learning as a general method can be easily adapted to the phenotyping of other similar diseases. Our study has limitations such as the limited size and quality of the training data. For future work, we plan to add genetic markers to the feature list. As conclusions, ADRD phenotyping through transfer learning resulted in more accurate model. And second, the prospective survival analysis provided a further validation of the model. And this is the end of my talk. Thank you.
Professor, it's a very nice presentation indeed.
Thank you.
I just want to know one point that why you have used only 10-fold validation. Have you tested for the other folding as well?
Sorry, what is validation?
You have used K10-fold validation, no?
You mean tenfold cross validation?
Yeah, only 10-fold you have used, or you have checked the other assumptions as well?
Well, we use tenfold cross validation because the smaller data set has smaller number of patients. So if we use the traditional method like dividing this into one training set, one validation set, then the size of the validation set it would be too small. So if we use tenfold cross validation, we can use the whole whole data set for validation, but we still don't have the overfitting problem in that way.
Yes, understood. Nice presentation indeed, Professor. Thank you.
Thank you.
Thank you, sir. Now I request Vishnu, sir. So do you have any questions?
Yeah, well, just a quick question. So, yeah, your survival analysis. So, what does it show about maybe like a future ADRD risk?
Sorry, what's the question again?
So, what does your the survival analysis show about a future ADRD risk?
Yeah, so the survival analysis basically shows that for those patients who are predicted with higher risk scores, they are more likely to have ADRD in the near future.
Okay.
Yeah.
Okay. All right. Thank you.
Thank you.
Thank you, sir. Now we are moving towards the next presentation. For the next presentation, I would like to call Pat Adine for the paper title, Key Challenges to Develop Agentic News AI on Flutter. I request the presenter to kindly proceed with their presentation.
Yeah. Good morning, everyone.
Good morning, sir. You can
Can you
proceed.
hear me? Can you hear me? Yeah.
Yes, sir. You are audible to us. See your screen.
Yeah. Thank you so much. And good morning, everyone. And today, can you hear me?
Yes, sir. You're audible.
Yeah. Today, I'm gonna present my research paper titled "Key Challenge to Develop Agentic News AI on Flutter." And agentic news AI uses machine learning algorithms to analyze history, generating engaging headlines optimized for click-through rates and automatically summarizing articles, allowing journalists to produce concise and relevant content efficiently while enhancing audience engagement. And that kind of AI provides multiple headlines based on core event elements and background information, ensuring engaging and relevant content for news articles. This enhances headline quality and reduce task effort, and as well as maintain perceived trust and control in the writing process. Nowadays, generative pattern transformer models generate attention-grabbing headlines by analyzing lexical and grammatical characteristics and enhancing reader engagement. Our goal is developing Flutter app that works like agentic AI. So, as you know, agentic AI operates autonomously and analyzing data, making decisions, and taking proactive actions without the human intervention. So our method is our app collect hot topics from international source with the open API and local sources. For the local sources, we have used HTML DOM reader, and we have two kind of main functions on our application. So very first is summarize news articles, and the second is neural machine translation functions. And nowadays, some kind of NLP, natural language methods to recommend very good recommendation for the news readers. Our application advantages are if user login from specific location, he can analyze user's locale and show up the news results in one's native language and a really productive summary for every single news. These methods aim to condense large volume of text into concise and informative and summaries while maintaining accuracy and objectivity of the original content. But there are some challenges for developing that kind of application. Very first is ethical challenge. AI raises concern about the algorithmic bias and potential erosion of the journalistic integrity. It is crucial for journalists to complement AI capabilities with their expertise to mitigate these ethical issues. So for the algorithmic bias, AI-powered news apps are susceptible to algorithmic bias, which can lead to spread misinformation and erosion of editorial oversight. Ensuring transparency and accountability in AI-driven content generation and recommendation system is crucial to maintain user trust. That's the very crucial thing. And sometimes it has also a risk of reputation or misinformations. So we have to ensure that the AI systems adhere to and maintain journalistic integrity is a significant challenge. And second problem is privacy and data security. AI-powered news apps often rely on user data to provide personalized experience, raising concern about the privacy and data security. Ensuring that user data is handled responsibly and securely is essential to maintaining trusts. So, third potential challenge was primary sources. So, in fact, that journalists rely on primary sources for their credibility and reliability. So sometimes the government, corporations, or other organizations suppress releases to communicate official information. So journalists regularly monitor these releases to gather factual data and quotes, conducting interview with the experts, eyewitnesses, and individuals directly involved in events in the cornerstone of the journalism. This interaction provides unique insights and the personal perspective, and that enhances the news stories. So sometimes we have social media sources as well, and some media has become indispensable tool for journalists. For example, platforms like X, formerly Twitter, Facebook, and Instagram serve as a real-time source for information, especially during the big news events. But again, journalists monitor these platforms to gather eyewitness accounts and videos and images as well. So we have to make a cross-check for these facts. Independent fact-checking organizations play a crucial role in the accuracy of claims made in the public discourse, such as journalists frequently consult these sites to ensure the information in their report is trustful. So those are the main challenges for developing agentic news AI application in the Flutter. For those challenges, we going to recommend some solutions. For example, performance and optimization problem. Optimize app performance by improving the cache management and reducing bandwidth consumption. For example, sometimes there is algorithmic bias, which means a risk of spreading misinformation and undermining editorial oversights. In that case, we're going to implement robust framework for accountability and transparency in the AI-driven systems. So in the conclusion, news writers like agentic AI employ combination and traditional and digital sources to stay updated with the current global events, while traditional sources like mainstream media and official statements remain vital. The social media and user-generated content have become essential component of modern journalism. However, the digital age also presents challenges such as the need for robust verification strategies and ethical implication of rapid information disseminations. By leveraging both established and emerging tools and techniques, again, agentic AI can continue to produce accurate and timely and impactful news content. However, challenges such as data privacy and also algorithmic bias and user fatigue must be addressed to ensure the success. For the future development, should focus on multimodal NLP and explainable AI and edge AI to further enhance the app's capabilities and user experiences. So AI models explicitly seed sources from headlines, news recommendations, showing where the information originates, and this ensures your users can verify content and understand basic of the AI choices. For example, AI can provide breakdown of why certain headline or news article summary is recommended for this case. And at the end of this presentation, we have developing a centralized data-powered news app using Flutter is a complex endeavor that requires careful consideration of technical and ethical and operational challenges as well. By addressing this challenge through optimized performance, ethical use of AI, and fostering collaboration, developers can create seamless and trustworthy user experience that leverages the full potential of agentic AI in the journalism. In particularly, we have used artificial intelligence to automatically translate news into the reader's native language and also to provide summary view instead of large amount of text when reading the detail. That is in case that is demo image of our beta version of our application, and there is international sources and local sources as well. And finally, I want to show you our demo application very briefly. For example, that in case there is a top news, which means which shows directly from international sources, but we are showing it that news is in Mongolian directly, and as well we have maybe scientific news as well, and finally we have Mongolian top news sites to produce some headlines and some summaries from
Sorry to interrupt,
the
sir.
Mongolian
But you have 1
news.
minute to conclude.
Yeah, thank you, sir. So, but in here, it is Mongolian top news sites and news headlines from them. And if we click into some of these news, it directly summarizes some sort of information from the main sources. To avoid the ethical problem, we have put read from directly sources button in here, and if you click there, there is a full source of this information. So that's all for today. Thank you for your attention. And is there any questions?
Thank you, sir.
Thank
I
you so
request
much.
session chairs to, sir, do you have any questions?
So I have a question. So does it translate to some other languages?
Yeah. Sorry, pardon. Will you repeat, please?
So can you do you know? Can you tell me if your software could translate this to other languages?
Translation. Okay.
Yes.
Yeah. So in Mongolia, first of all, I am from Mongolia, especially from the University of the Humanities in Mongolia. So we have developed two kind of software. Very first is the University of the Humanities translation, and second is University of the Humanities artificial intelligence. So that was built in 2024. And for example, neural machine translation software is here. Sorry. Maybe you can go to translation software is located in our university. If you want to show the full paper of my translation system, you can show from the ICTIS project from the European Union and click the that
well, what I meant is actually from your app, the news app that you're showing. Can you translate within the app, like to English or some other language?
Because we have translation API on there.
Oh, okay.
So we can just call from our University of the server, which is located in my Mongolian university, and we can call IP from this and they show up the result. That's all.
Okay. Thank you.
Okay. Thank you so much.
Thank you, sir. Now moving towards the next presenter. For the next presentation, I would like to call Dimitri A. for the paper title Mass Parallel Slipso Net-Based Solving PDEs on FPGA for Embedded Control. I request the presenter to kindly proceed with their presentation.
Hello,
Hello, sir. You are audible to us.
Yes, I believe you can see my slides. And
Yes, sir. Your screen
my
is visible to us.
congratulations. My congratulations because you attend a great event, the Second Revolution, where we unite mathematics and computer science. The first was when sinus, cosinus, exponent were implemented in hardware. I remember I was puzzled at the university how they implement mathematical functions when we have only addition, multiplication, subtraction, division in our computers. And we needed to unite to make a law of Taylor series, for instance, with programming to understand and implement it. Here we unite partial differential equations and FPGA to implement solution process of FPD partial differential equations PDAs in hardware. So we are absorbed in embedded applications. We work with microcontrollers, FPGA. We approach direct coding, model-driven development, though we prefer using FPGA and formal method-driven development for fast embedded control of very fast processes, such as nuclear reaction, such as hypersonic flying objects, and others. We call it formal method driven because UML is too bulky for embedded applications, and applying formal methods allows us to prove our correctness of our embedded system to produce reliable embedded systems. So here you can see a basic workflow which includes a tool chain and the working hardware. So here we start from boundary problem, which is specified using partial differential equation. We have a base of stencils, and studying convergence issues, we produce finite difference expression to resolve this problem in math parallel way on a mesh. Then we compile this expression into Slipsov net to simulate it, to study properties, to prove its correctness. And here we are using integer value approximation or negative integer approximation. It is synchronous Slipsov net, which we also call Slipsov-Salvitsky net. By the way, Anatoly Slipsov is attending our conference, and we are sending our kind greetings for this outstanding Ukrainian scientist. You can find Anatoly Ilyich Slipsov on the list of participants. When we compile Slipsov.net into Verilog code and upload it to FPGA, and it is constantly running, reading sensors attached to the boundary, and taking values for some nodes and transmit them to actuators. So it is very efficient and fast control for turbines, for engines, for controlling trajectories, etc. And now let us have a look at an example, Laplace equation. For instance, we apply this non-usual stencil with 8 neighbors, so-called Moore neighborhood stencil, and we replace derivatives by the corresponding difference expressions, like here for the second order derivative. And finally, we obtain finite difference expression. So, in my opinion, there is intrinsic connection with two very interesting formal systems. At first, cellular automata, because we are using in the following implementation integer approximation, and with artificial intelligence, because this finite difference expression represents connection to recalculate values. It is like trained neural network, because we have all these optimal coefficients to resolve this equation. And within this reward automaton structure, we have not only one-way transmission of signal, but we have transmission to the 8 neighbors. So it is more general construct than neural network. So please think in this way, and it is very interesting maybe approach we are developing. Here we present terminal condition when we achieve certain accuracy of computation and provide a numerical example for constant boundary conditions. So you can see how it looks like. We have two-dimensional space, and we need the third dimension to represent our function. So you can imagine how cells of this automaton look like with these colors which represent the corresponding values. And we have a unified approach, Slipsovnet programming approach. You can find lots of references on this dedicated page, including its review on ICM Tech News. By the way, it is bipartite directed graph, two kinds of vertices, places, and transitions connected by weighted arcs. And inside places, there are tokens which move as the result of transition firing. We managed to prove that it is Turing-complete system and runs exponentially faster than PetriNet, so we can compute on it. Here we illustrate an example of transition firing rule. So all the copies of transitions fire simultaneously, and here we are using synchronous approach for the maximal performance. So we compute multiplicity of arcs, then transition, and then change marking according to the next marking expression. We translate our finite difference expression in patterns for one node, and we are using different grouping of terms, which is presented in detail in our paper. For instance, here we have a brief net that computes one iteration in one time cycle on entire mesh, but its accuracy maybe is not so good. The next one computes one iteration in 3 time cycles and provides better accuracy. We illustrate how we compose mesh. Here, modest size of lattice, 5 by 5. If we remove, we do not consider borders because we recalculate values only for internal nodes. It is 3 by 3 mesh. So we can simulate, analyze this net, and finally we can specify it with no regard to the dimension using our approach of infinite Petri net and parametric expression. And we can study properties with no regard to dimension. We study properties of patterns. Because of it, we call them infinite nets. And finally, we compose these nets into Verilog code. And here we specially treat accuracy. You can see round H value. It means when you should round to upper or lower value. And because of it, some issues of convergence can depend in this non-negative integer approximation. We illustrate Verilog with circuits synthesized in automatic way. Here we have one node to the left and the mesh to the right. Because it was automatically placed, we can maybe just guess the 4 by 4 structure, 3 by 3 structure actually, if we take internal part of this mesh. So we are interested in code which is uploaded to the device. And when we run the obtained code on real life FPGA, we studied benchmarks. So benchmarks are very optimistic because very small devices like Tang Nano for 10 pounds FPGA with Govin chip with can run mesh up to 10 by 10 very fast, and you can see the accuracy, 1000th accuracy. If we create bigger mesh and maybe we require more powerful FPGA, we can run also with the next level of accuracy. So benchmarks show that our approach suits very fast control in special applications, and we invite interested people to join this research with maybe some joint project proposals. So, if we'd like to make some conclusions on our research, I would like to mention that we provide fast mass parallel numerical solving of optimal control problems specified by PDE. We apply formal methods, so it is formal method-driven development, a new kind compared to model-driven development. We use finite difference methods and graphical language of infinite Slipsov nets to achieve embedded control of fast processes in real-time applications using FPGA. And here you can see our recent advances. More detailed explanations you can find in this paper, and our other co-author Tatiana Shmelyova provides special part of it with respect to interconnects for high performance computing, six-dimensional interconnects like for Fugaku supercomputer. The second paper was published with a legend, Yuichiro Ajima from Fujitsu, who created Tofu-D interconnect, and apprentices from Rolls-Royce. So we are very close to the application domain. You can find our other approaches for microcontrollers and FPGA in the third paper, and theoretical background where we prove Turing completeness in the fourth paper in this list. So please join this very interesting second revolution when we will be having partial differential equation on a chip which runs very fast to control engines, to control very fast processes like thermonuclear reaction and others. So we have achieved this great performance. Thank you for your attention.
Thank you, sir. I request session chair, sir. Sir, do you have any questions?
So I have a question. So you gave some applications like thermonuclear. So can you give some other examples of real-time systems that can be benefited from this?
Yeah, our close neighbors in Dhabi, Rolls-Royce, so they produce engines for such big planes as Airbus 250 and 80. It is Trent 1000 turbine. And we are not applying this directly yet, but we are looking on time characteristics of this engine and try to understand how we can control some subsystems. So we are approaching this kind of application for turbines, and many maybe for conventional engines it will be easier for car engines as well. So it is other application and trajectory of hypersonic objects when they are moving very fast, and also control of their systems is also rather significant application. Colliders require our colleagues in the University of Dhabi. We have a brilliant group of researchers, including nuclear physicists, physics and deep work with colliders and CERN, so it is also in scope of our evaluations. So it is how we approach the very interesting domain of fast control in real time for very fast processes.
Okay. Well, that is great. Nice presentation. Thank you.
You're welcome.
Thank you, sir. Now let's move towards the closing remark. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during the 10th version and all the previous 9th version of the conference. We'll be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 6 months. Kindly cooperate with the team of ICTIS 2025. I also thank our session chair for chairing the session. Sir, this is the token of appreciation and love to the team of GR Foundation and partners.
So the proceedings will appear
Thank
in
you,
half
sir.
a year.
Thank you.
Thank you, sir. Now, I would love to extend my gratitude towards our next session chair. Sir, this is the token of appreciation and love from the team of GR Foundation and partners.
Thank you so much. Thank you.
Thank you, everyone, for being a part of this conference. Now, I request everyone to kindly turn on their cameras for a
So I
quick
think
virtual
somebody had a
snap.
question in between.
Yeah, but
Yes, sir.
could you comment when proceedings are expected to appear? Half a year, you
Sir,
said.
The
So long time.
publication will be live. The publication will be live within 6 to 7 months.
Oh, and it will appear on the
Yes,
Springer.
sir, you'll be receiving a mail from ICTIS team on your registered email ID. When the publication will be live, you will be receiving a mail from our side with the proceeding itself.
And it will be
Okay.
indexed in Scopus.
Yes, sir.
Okay, thank you.
For indexing and all, you please mail to the conference team. They will be giving you a clear answer over it.
Thank you.
Thank you. Now I request everyone to
Thank you so
kindly
much.
turn on their cameras for a quick virtual snapshot of the conference.
Karthik, I kindly request you to please share the photo as well. Thank you.
Okay, sir.
Sorry, I'm having issues with my camera, so I apologize. I'll leave. It's fine. Thank you so much. Huh?
Thank you, sir. Thank you, everyone, for being a part of this conference. Let's meet you in 11th version in 2026.
Thank you. Thank you, all of you. Have a good day.
Thank you, bye.
Thank you,
Thank you.
sir.
Bye.
Thank you,
Thank
ma'am.
you. Bye.
Everyone.
Thank
Bye.
you.
Thank you.
Goodbye.
Goodbye, sir.